Given y is this gross square root, and we're asked to find its derivative, great, using logarithmic differentiation. Okay, so the whole idea with 3 is that we have to use a bunch of our log rules, and then we can take a derivative. So a couple things we need in our toolbox to attack a logarithmic differentiation question will first be, if I have natural log of a number to an exponent, I'm allowed to bring the exponent out in front, and that doesn't change my expression. If I have two things being multiplied together, I can expand their log to be the sum of those two terms. And if I have two things being divided in a log, I get their difference. Okay, so this is just the algebra we need, the pre-calc, whatever you call it. And the only piece of calculus we need really is that the derivative of natural log of a function is equal to f prime of x over f of x. Okay, we know that the derivative of just ln of x is 1 over x, but don't confuse this with any other function. If the inside function is not x, we don't know that its derivative is 1 over x. So please just use this as a rule of thumb, okay? So let's just do a bunch of log decomposition here. Let's first just write this as a or as an exponent. So remember, square roots are the same thing as a fractional exponent of 1/2. So this thing is just that, okay? So first up, we're gonna use this guy here. Well, first up, we actually have to take a log. We haven't taken a log yet. So we're gonna do ln of everything. So we'll have ln of y equals ln of this whole thing that I have. Okay. So, like I said, let's use this green one first and bring the 1/2 out in front. So we'll have ln of y is equal to 1/2 ln of this fraction. Remember, I said if we have a fraction in our log, we can break it up by subtracting the numerator and the denominator. So using this one now, using this one now, why is my marker broken? All right, whatever, I don't know. Okay, so let's do that. We have ln of y is equal to, I'm gonna leave the 1/2 out in front and deal with it later, okay? So we're gonna have ln of the numerator minus ln of the denominator. Okay? There's nothing we can do here yet because all we have is subtraction. We have multiplication, division, and exponent rules. We don't have anything for subtraction, so we're gonna leave that there. This guy, though, I have an exponent, so we can bring that down in front. So now we're working with ln of y is 1/2 times ln 5 minus e to the 4x minus 3 ln of 3x to the 7 plus 7x plus 1. All right, it looks like we can't go any further here, all right? Once we've exhausted all of our log rules, we are ready to take a derivative, okay? So let's do ddx of every term because we're asked to find dy dx, okay? So we'll have ddx of ln of y is equal to, again, we can bring this 1/2 out in front because it does not depend on x like that, and it was factored out of everything already, so we're not committing algebra fraud. So then derivative of this whole thing here. Okay. Derivative of ln of y with respect to x is going to give us 1 over y times this implicit differentiation dy dx. All right, so let's take this 1/2 and then do the derivative of each of these terms. So derivative of this piece is going to be a derivative of this divided by the original. So we'll have minus 4e to the 4x over 5 minus e to the 4x minus derivative of this piece. So we have a 3 out in front. So 3 times this derivative. So derivative of our polynomial will give us 21x to the 6th plus 7 divided by the original. Okay, we're almost done. We were asked for dy dx. Right now I have dy dx times 1 over y. So let's multiply that y up. So we'll have dy dx is equal to 1/2. This whole monstrosity. I'm just going to leave this 3 out here because I don't care about it. Okay, times y. But let's plug y back in. Okay, this was y. So let's write our final answer as this, but plugging in our original. So times square root 5 minus e to the 4x over 3x7 plus 7x plus 1 cubed. Gross. But we did it. All right. Of course, it's the grossest problems that have follow-up questions, but let's not worry. All right? We're asked to find the slope of the tangent line that is tangent to the point 0, 2. We're still working with the same expression as before. But good news, we already found its derivative because dy dx, if I evaluate this at 0, 2, I'm gonna have the slope of the tangent line at 0, 2. Okay, so dy dx, so we just want the slope. We don't need the equation of the line, so that's nice. Okay, so let's think about this real quick. This is x, and this is y. This whole piece is y. Okay? So y is 2. So we're going to have 1/2 times this guy with 0 plugged in. A lot of things are going to simplify here. So remember, e to the 0 is just 1. So that'll help us out here. And then we're going to have 0 plus 7 over 0 plus 0 plus 1 times y, which is 2. Okay? So this is going to be equal to 1/2. I'm going to have minus 4, 5 minus 1, minus 3 times 7 times 2. This 2 cancels here. And then we're left with, well, negative 4 over 4 minus 21. So it'll be minus 1 minus 21, which is negative 22. That looks terribly incorrect, but whatever. I think it's correct.